Project 3.3.2, CHUMP Program EEPROM. This is the second part of the CHUMP circuit. It includes an EEPROM IC, a dual 7-segment display, and an astable multivibrator subcircuit. Right now it's showing the first line of the code written in the first project, which is the 16-line code that's going to swap two variables without the need for a third. It's being shown in hex, and we can cycle through it right now from line 1 to line 16. As well, the program counter is controlling the timing of the circuit, so that was just manual mode, but it can also go in freestanding mode. It can speed up with the potentiometer and slow right down. The real main controller of this circuit is the EEPROM, but it starts as a storage device, and it has to have code burned or written onto it. Code is written on through the use of an EEPROM burner. Right here we have two 595 shift registers and an Arduino Nano. The shift registers just give the Nano some extra pins. Right now they're on the address pins of the EEPROM. There are 11 address pins, and so there are 2 to the 11th unique addresses. You can think of them like pages in a book. If this EEPROM is a book, there are 2,048 unique pages that the Nano here wants to write to. On the page, it can write one unique 8-bit value per page. So to actually write it, there are 3 control pins, the write enable, output enable, and chip enable. They're all active low, so to write, you need the chip enable and write enable low with the output enable high, if you're outputting vice versa. There are also these input output pins, IO pins. They're being used as inputs here because you're writing to it. And while the Nano is flipping through each page, it's going to pulse the write enable high. It has to be between 100 and 1,000 nanoseconds. And when it does that, it's going the EEPROM is going to latch whatever is on these input pins into that page. It's going to write it into that page. And the Nano can move on and flip through the pages as such. In this case, we're going to use 32 unique addresses or pages. So as mentioned before, the timing is controlled by the program counter. However, the program counter only has 4 outputs, and these are going to A0 to A3, addresses 0 to 3. But that's only 16 bits, that's 0 to 15. And we need 32, as I just said. But there is a way to do this. So first of all, it should be mentioned that the EEPROM now is outputting. So output enable is low and write enable is high. The IO pins are outputs, and as such, they're going to the 7 segments. Now the 7 segments each have A through G. There's A1 for the left, A2 for the right, so on and so forth. Now the outputs are connected in parallel to both. So A1 is connected to A2, which is connected to the 7th output. A is the most significant and G is the least. Now, this might seem like it would just present the same number on both 7 segments, but that is controlled by the astable multivibrator. This oscillator is really critical in the circuit, and it has 2 very important roles. First of all, it's providing ground to each segment, to each 7 segment. So when one side goes high, let's take this NPN here, it's going to go to an inverter set up here, just another NPN, which is going to turn its high to a low, and it's going to ground the left segment. This means that the grounds are actually being oscillated so that no 7 segment will be on at the same time, but you can't see it due to persistence of vision. The second important function is that this NPN is going to the 5th address line. The 5th address line unlocks another 16 bits, as it is the 5th bit. It is the bit representing 16, and it changes from the usable bits or addresses from 16 to 32. Now, if this is high, normally the input output lines, you wouldn't be able to access the normal 2 at once. However, this is circumvented with the oscillator. What the oscillator is doing is it's turning that 5th address line on and off really quickly. Now, to get 2 numbers side by side, let's take 60 here. Now, 60 could be, let's say it's our 4th address or 5th address, okay? So on the right side, in address number 5, we want a 0 coming in. So when we code this EEPROM, we need to put in a 0 at address 5. Directly 16 above, we need to put its partner here, the left side, which is a 6. So we want to program it so that the partners for this next line, 6 and 1, need to be 16 addresses apart. What happens here is that when the 5th address line is turning on and off, all the other bits of these are the same, except for that 5th bit. So we can show both bits at once. The input-output lines here are actually switching between line 6 and line 22 very fast and very rapidly at the same time that the grounds are being switched, so that it's showing the numbers at the same time and it's appearing as if they're both there, even when they're not. That's the gist of it, and that's the circuit. I hope you have a great day. Thank you for watching.